Okay, so let's talk about streams and files. So there are different ways that we do input-output with, with Java. Basically ways to read files, although you'll find out when we talk about streams that we can read and write things that are not files as well. So there are basically four ways. So the first way is with streams. That's kind of the main way, the standard way that we read and write files, or not just files, actually, it's the way we read, or it's the way we do input output into a Java program. We also have the scanner class, which I think you're familiar with. I've shown slides about that, and I suggested that you use that on some of these assignments that you've already done. That's quite a bit like a stream. In fact, you will often attach it to a stream or attach it to a file, and we'll talk a little bit more about that. You have a class called the files class, which provides a way to read a whole file all at once. And then you have a random access file class, which allows you to read and write to and from random locations in a file. So that's kind of the opposite of a stream. The way a stream works is it just reads the file from beginning to end, or really what I should say is it reads the source of bytes from beginning to end, or it writes the source of bytes from beginning to end. But with a random access file, you can jump around in the file and read and write from various places. We don't normally need that, but it's useful to have a class for it when we do need it. Okay, so let's focus at first on streams. So streams, Java I/O streams, are for writing data to or reading data from files or from other sources. And when I say other sources, that could be something like a network socket. It could be another thread. It can be a lot of different places, but mostly when we're reading and writing, we're reading and writing from files. So that's usually what we think of. You really have two choices with streams. You're either going to be reading binary data, binary formatted data, or text data. If you're reading binary data, you want to use the input stream for reading, the input stream class, or the output stream class for writing, or one of its subclasses. And so these are stream classes for reading and writing bytes, or in other words, binary formatted data. But often we're working with text, either characters or strings. And when that's what we're doing, it's a lot easier to use the reader and writer classes. You can use input stream and output stream classes for text, but then you have to worry about converting those bytes into strings. And if you use readers and writers, that happens automatically for you. So that's really how you decide if you're using input streams and output streams or readers and writers, is whether you're reading text data or not. So I already mentioned these other classes, but here's a quick overview of what they do. So the file class represents a file in the file system, but it's not directly used to read the file. It's often what we do is we create a file object to represent a file, and then we pass it to some other class. We pass it to a scanner or pass it to a stream, something like that, and then we read it from the stream. But there is one useful thing that we use the file class for, in addition to just representing a file, is it will tell us if the file exists or not. So we can create a file object from a stream, which is supposed to represent a path to that file, but we can create it with any path, whether that path represents a valid file or not. So then to find out if there actually is a file with that name at that location, we call the exists method on the object. So that's a common use for that one. The scanner class, we've talked briefly about it, but its purpose is to tokenize the stream input. And what we mean by that is it will break the data up. If you are reading from a stream, then you're just going to get each byte. In general, we'll talk more about this, but in general, it's one byte at a time, or they come in order that they appear in the source, and you just get all of them. But sometimes it's useful to be able to break them up. So for example, we might want to read words separated by white space. That's what you did. That's what you wanted when you were reading your dictionary file for your spelling corrector. And so you can set a scanner up to delimit by whatever characters you want. And by using a regular expression, you have a lot of power about what those delimit characters are. And so that would allow you to read one token at a time. And by token, we really just mean a string that fits whatever definition you want it to fit. So we could say we want a token is a word. And so then we would set up our scanner so it delimits by everything that would delimit words, which would be white space, new line characters, comments, things like that. But by using a regular expression, you can delimit by whatever you want. Those delimit characters are discarded, and every time you read, you get the next string that fits the criteria that you're looking for. So that can be really useful for certain kinds of applications, and that's why you've already used it. As I mentioned, we have the files class, which is for reading and writing, or reading and copying, writing, whatever, whole files. And I find that I don't use that a lot, but sometimes it's really useful. And then I already talked about what the random access file class is. So we're going to look at each of these three and see some code examples as we go. But before we do that, we're going to talk more about streams, because that's kind of the primary way that we do input-output in Java. Okay, so first of all, input stream. And if you have questions as I go, definitely just raise your hand and ask me as I go. But the input stream is an interface. It's used to read bytes, as I said before, sequentially from a data source. And we have several classes that implement it. The most common one is file input stream. That's the one you'll use by far the most. But there's also a piped input stream. That allows you to read from one thread. You can read data coming from another thread by using a combination of a piped input stream and a piped output stream. I find that I don't usually do that, because usually if I have a network connection, there's another built-in way to do it, but that is available to you to read across threads. Another way to get an input stream is to use a URL connection. When we start doing the Family Maps server, you'll learn more about that. But we need to be able to get a stream to read data from a server. So we'll use URL connection.get input stream, and that will return a stream that will read data off of a server. Similarly, HTTP exchange.get request body is another way to read data. Usually we will do that when you'll use that method when you're using your server. You could also get a stream from a result set if you're doing JDBC, which is Java Database Connectivity. We're going to talk about JDBC hopefully starting, well, we'll talk about databases starting today, but we probably won't get to JDBC until tomorrow. But that is one thing that you can do if you have a large amount of data, maybe a file stored in a database table, then you could read it from a result set by calling get binary stream. There are actually many more examples of ways that you can get streams to read, but as I said before, the most common one, and the one you're going to use probably quite a bit as you do Java programming, will be the file input stream. Okay. There are a lot of different features that you might want to be able to enable when you're reading data from a stream. So for example, if the data is compressed that you're reading, you might want to decompress it as you read it in. If it's encrypted, you might want to decrypt it. And there are other things you might want to do. You might want to compute a digest of a stream, which is just a fixed length value summary of the data. And you might want to count the bytes or count the lines. You might want to buffer the data, store it in some kind of buffer so you can read it efficiently. So there are lots of things you might want to do, and that it works in a really convenient, nice way with streams in Java. We have a class called a filter input stream, and that is a class that takes another input stream as a parameter, and that allows you to connect streams together. So for example, you can take a file input stream. With a file input stream, you connect it to a file. So that's going to read bytes from a file. But what if those bytes are zipped? Then you can attach an unzip or a gzip input stream to your file input stream. And now you're not only reading the bytes, but when you get the bytes out of the other end of this zip input stream, they're unzipped. So you can connect streams together to do things for you in kind of like a chain or a pipeline. And I'll show you examples of that in a minute. That'll become more clear. Okay, so this kind of says what I just said. You open an input stream on some data source, for example, a file or a socket. Then you wrap that in one or more filter input streams that provide the features that you want. So that could decompress your data and then decrypt it, for example, as you read it in. So maybe you have an encrypted compressed file. And so you could attach a file input stream to it, attach an unzip input stream to that, and then attach a decrypt input stream to that. And when you read out of the end of the decrypt input stream, you get the data from the file, but it's both unzipped and decrypted when you get it. So that's really convenient. So each filter input stream, each input stream that is a subclass of filter input stream, reads data from whatever is the next input stream in line. Okay, and I'm going to show examples of that, but let's just talk about output streams first of all. So streams kind of come in pairs. You have input streams and you have output streams. Input streams obviously are for reading and output streams are for writing. And you basically have a one-to-one correspondence. So every way that you can get an input stream, you can also get an output stream. There is a file input stream and there's a file output stream. So they're kind of matched pairs. And just like we had filtered input streams, we have filtered output streams. So if you want to take a string and write it out, but have it be zipped and compressed when it gets to the destination, you could do that. You'd set up a file output stream, set up a zip output stream and attach it to that, and then an encryption output stream and attach it to that. And now you've got this pipeline of 3 streams, and when you write bytes on the end, it gets all the way, when you write bytes on one end, it gets all the way to the other end, and all the things that those streams can do in sequence, they do as they're writing the data. Okay, so this is kind of the same old thing. Same things that I said about filter input streams apply to filter output streams. Any stream that is a filter output stream, that means it connects to another stream. So it takes another stream as a parameter and allows you to set up these pipelines of streams. Okay, so with that, let's look at an example. We're going to look at both a compress and a decompress example that uses streams. So first of all, let's learn how let's start with decompress actually. So we are assuming that we've got a file zipped in gzip format, and how would we read that into Java? I meant to click that, not to go to the next slide. Okay, so here's my code example, and all the examples that I use in class are accessible to you. If you go to the module for this topic, you will find a link, and if you click on that link, you can find both the slides that I'm showing you and all of the source code. Okay, so this is our decompress example. So first of all, we have a main method, and it just creates an instance of itself, of its own class, and then it checks to make sure that it has 2 parameters. I'm trying to remember what the second parameter is. Okay, input file and output file. So the way this example works, we take a file that is not compressed and we read it in and we write it out as a compressed file. So the first parameter is the input file name. The second parameter is the output file name. So this is the uncompressed file and this is the compressed file that we're going to make. Okay, so first of all, we check and make sure that we specified 2 parameters, and if we did, we call this compress object's decompress file method and pass those 2 parameters in. So they come in right here as an input file path and an output file path. And the first thing that we do is we convert those strings to file objects. So that's a pretty common thing to do with file IO. So we create our input file object and our output file object, and then we open up a pipeline of streams. So remember when we did exceptions, we talked about try with resources. That's the way you can open resources and have them be auto-closed when you're through, when you leave the try block. So within our try, right here, I have set up a pipeline of streams. So I start with my file input stream that attaches to the input file, and then I attach a buffered input stream to that. So notice that the reference here is called FIS. That's what I pass as a parameter to buffered input stream. A buffered input stream is a stream that reads really efficiently. So instead of reading 1 byte at a time, it will read a group of bytes. And I can control how big the buffer is if I want to specify a second parameter, but usually the default is pretty good, so I don't usually specify that. So what this means is if I read some bytes from this buffered input stream, it will first of all check to see if it already has those from a prior read. If it doesn't, it will ask the file input stream for some bytes, but it may read more than I asked for. So let's say that when I called read on here, I asked for 10 bytes. It may read 1,000 bytes. And it will store those internally in some kind of a buffer, probably an array. And then if it doesn't need to return everything it read, it will just return the next number that I asked for. And if I ask for more, it will check its buffer to see if it has those buffered already. If it does, it will return that. And it won't read again from the file input stream until it needs to. So that allows you to very easily and efficiently read from a file, but not have to worry too much about making it efficient. It will be efficient because you attached a buffered input stream to it. So it's going to internally be buffering, and it will do fewer read operations than it would otherwise do. Does that make sense? Are there any questions about that, about what the buffered input stream does? Okay. And then the next thing we do is we attach a gzip input stream to that. And so that means that as I read the data in, it's going to read it in efficiently because I've got a buffered input stream. But then any data that comes out of the end of this buffered input stream and into my gzip input stream is going to be zipped. So I end up getting zipped data when I read it. It's already pre-zipped for me. Then I'm going to create my file output stream and attach that to the output file, and then attach a buffered output stream to that file output stream. And so that's going to, I think I might have said that backwards. We are going to read a zipped file. So the file is already zipped. And when I read this in, this gzip input stream is unzipping. So it's unzipping the data. It's unzipping a zipped file. And then when I write it out, I'm going to write it out efficiently because I'm going to write it to the buffered output stream, which is going to write it to my file output stream. So it ends up unzipped in a separate file. Okay, so now let's look at the code for actually doing that reading and writing. So first of all, Sarah, yeah, I see you have a question.
Yeah, I was just wondering, so what would happen if you didn't use the buffered input or output stream?
It would just be inefficient. You'd be doing a whole lot of reads and writes to your disk, so it would be slower. It'd be very slow.
Okay, got it. Thank you.
Okay, you're welcome. You wouldn't be able to see any other problem. I mean, it would still work. It would just take a lot longer than it should. Okay, so if we look right here, we are setting up a buffer. We're setting up a place where we can store bytes as we read them in. And so this is a pretty common programming idiom. It's common that we do it this way when we're reading files. You'll get used to seeing code that looks like this. So first of all, we have created a byte array that we can read our bytes into. And notice that we've said its size is chunk size. That's declared as a constant right here. And we're just saying we're going to read 512 bytes. And it's always good to read in powers of 2, and computers work efficiently with 512 and 1024. Their processors are made to work efficiently that way. So that's a good number to pick for a buffer size. Okay, then we need to keep track of the bytes that we actually read with each read call, because it's possible that this buffer size, maybe we're reading a file that doesn't have 512 bytes, or we're going to read it multiple times, and the last time we read it, there won't be 512 bytes left. So we need to know how many we actually read. So what we do within our while loop is we call the zip input streams read method. Notice that we created this pipeline, and we're reading from the end of it. We're reading from the last one that we created because we want all these things to happen. We want it to come from the file, be buffered, and then be unzipped. Okay, so we're going to read it, and what we get back will go into this bytes read. Yeah, question, Kellen?
Do you mean zipped, not de-zipped, unzipped?
No, it's unzipping it. I think I said it backwards at first. So in this example, it's decompressing. So the file is zipped, and we're unzipping it as we read it in.
Okay, that makes sense.
Okay, so as we read it, we read the bytes, and they go into this bytes read. That's the, just a minute. Okay, so first of all, we're reading them into this chunk variable. So we pass a byte array into the read method, and that's where the bytes go. As they get read, they end up in this chunk variable. And we need to know how many bytes we actually read, so the method returns the number of bytes read. And then as long as that number is greater than 0, our read was successful and we got some bytes. So we'll go into our while loop. As soon as it's not greater than 0, that means we've gotten to the end of the source of bytes. There's nothing else to read. And so we're going to stop at that point. So each time we read something into this chunk array, we're going to call buffered output stream. This is the buffered output stream, and we're going to call write. And we pass in the bytes we want to write. We say we want to start writing at position 0. In theory, you could pass an array and read from somewhere in the middle of it, but you almost never have a reason to do that. So you'll almost always want this to be 0 to just say start from the beginning of this array and write however many we read. And that's going to be 512 as long as there were 512 to read. So that will read in, decompress as it reads, and then write it out as a decompressed file. These examples are kind of cool because you could write a light version of a zip utility just with this code that I'm showing you. All right, so are there any questions about that decompress example? No? Okay. So I also have this legacy decompress example. I'm not going to go through that. The only difference between these two examples is this one uses try with resources and this uses a try finally. So you can look at that on your own if you want to. Okay, now let's look at the reverse of that. Let's look and see how we compress bytes. So now in this example, we are specifying two files again, but now we are specifying an uncompressed file as the input file, and we're outputting it as a compressed file. So a lot of the code looks the same. I'll skip over some of it. We got the same chunk size variable. Our main method looks about the same. We're creating an instance of the class. We're checking to make sure we got two parameters, both an input file name and an output file name, and we're calling the compress file method. Inside that method, we create two file objects. Notice that this method is declaring that it throws IO exception, and I didn't point that out on the last example, but it did too. Just about anything that you can do to interact with a file can generate an IO exception, so you have to deal with those. Okay, so we've created our two files, and now we have created our file input stream and our buffered input stream attached to that, so we want to read efficiently. Remember, we're reading unzipped data with this, because our point with this example is to read an unzipped file and zip it. So we have our file output stream attached to a buffered output stream, attached to a gzip output stream, and that will zip the data as we write it. And then this looks the same here. So we have our chunk variable, our bytes read. We use the same idiom here for reading bytes from within a while loop, and then we write them onto the zip output stream as we read them one chunk at a time. Okay, so are there any questions about that? So if you think about what we're doing here, these streams are pretty cool. They're pretty useful. What we were able to do is kind of chain some data, some capabilities together without really knowing how to do those things. You don't have to know how to convert bytes to zipped bytes in order to do this, because there's already a zip output stream that does know how to do that. So all you have to do is use it and attach it to whatever stream you want. And we could do the same thing if we wanted to write zipped data out to some kind of a server. We would just get an output stream on that server, and we would attach a buffered output stream and attach a zip, and then we'd be writing zipped out zip data to that server. We could do the same thing to a thread. If we had another thread, we would use a piped output stream and write to a thread. So there's a lot of power and a lot of flexibility here. It's not just for zipping and unzipping, it's for doing whatever you have a stream for. If we wanted to encrypt and decrypt, the example would be almost exactly the same. And the nice thing about this is the way we would code it would be the same. The structure of this algorithm would be the same regardless of what we were doing. We would just attach the appropriate streams together and we'd get the behavior that we want while writing code that's almost identical. So that is really nice. It's a really nice abstraction for how that works. Okay, so are there any questions about input streams, output streams, or filter streams, and how we're connecting them together to get this sophisticated behavior? Everybody good with that? Okay, we're probably getting close to a time where I should take a break. I'm going to just check and see how much more I have on streams here. We have a little bit on formatted data. Yeah, I'm going to probably go another 5 minutes or so, maybe 10, and then we'll take a break. Okay, so I've showed these examples. Reading and writing bytes is not always what we want to do. Usually you're reading and writing the bytes because you want to convert them to something else. We don't usually like working directly with bytes. Sometimes we use bytes when we're dealing with image files or something, but usually we want data types. And so we have data input streams and data output streams that we can attach, and those are filter streams as well. So we can attach them to any other kind of stream. And then that provides some other methods. So in the previous examples, you saw that I was reading and writing bytes. But if you attach a data input stream, then you can read and write data types. So for example, you can call a read int method, or a read float method, or a read boolean method. That assumes that you know which data types are in the file and what order that they appear, but we often would know that. We would be reading a file and we know what its structure is, and we want to make it easy to read, so we would attach a data input stream and convert it to whatever the data types are that we want to read. Same thing with an output stream. You could write an int, you could write a float, you could write a boolean by calling the appropriate methods on a data output stream. Okay, so that is information about writing binary data, but probably more often than writing binary data, you're going to be writing text data and reading text data. So you could do that with input streams and output streams, but like I said before, you'd have to be converting those bytes to strings, which is just an extra step. And there's no reason to do that because you can use readers and writers instead. So readers are just about exactly like input streams. And for every input stream class, there's probably a corresponding reader class. And that is for reading character data. And we have the same thing for writers. So if you know you're working with text files, use readers and writers instead of input streams and output streams. We have a copy file example here that I showed in the Java Fundamentals lecture, so I'm not going to show it again. You can look at that on your own, but that uses readers and writers to read a text file in and write the text file out. So the code looks quite a bit like the compress and decompress examples, but since it's working with text data, it is using readers and writers. And then one other thing that's useful here, we had input streams and output streams before we had readers and writers. I don't remember what version they added these readers and writers to Java. It was a long time ago, but I had been programming in Java before that. And we used to have to always convert our bytes to text when we wanted to, and then we got readers and writers. But because of that, there is a lot of code may have an input stream, but you want to convert it to a reader. So for example, maybe you're using some library that somebody wrote, and you want to use the library, but at the point where you get to read data in, it's providing you an input stream. But you know the data that you're reading from that stream is going to be text data, and you'd like to read it using a reader class. So what we have is an input stream reader. So that is a class which is actually a reader. It's a reader class, which means that you're going to get text data out of it, but it's made for attaching to an input stream. So instead of taking another input stream as a parameter, instead of taking another reader as a parameter, it takes an input stream as a parameter. So you can think of that as like a pipeline that converts between two different kinds of pipes. Hopefully none of you have had to do plumbing, because I don't find it to be very enjoyable, but sometimes when something goes wrong in my house, I work with the plumbing. And one of the things that you learn is if you have different kinds of pipes that need to connect, you have to use special connectors to connect different kinds of pipes together. You can think of this as that connector. So this allows you to connect readers to input streams. Normally they don't connect, they're different kinds of things. But by putting an input stream in the middle, you can connect them. And you can do the same thing with an output stream writer. That will take an output stream as a parameter, so it's a writer, so you can write text data on it, but it will connect to a stream, and then it will do the conversion from text to bytes for you. So those are very useful classes. Okay, often we're working with text, and so we have a print writer class that makes it really easy to print data out on a chain or pipeline of writers. And you've actually been using it. When you call system.out, that gives you an instance of the print writer class. So all the methods that you're used to using, which is print or print line or printf, those methods come from the print writer class. So if you want to, you can use those same methods to write to a file, for example. If you attach a file writer to a file, and then you attach a print writer to that, you can call whatever your reference name is .println or .print or .printf. So that's very useful to do. And the copy file example does exactly that. So when you look at that example again, you'll see that. Okay. And then the scanner class, I've already talked about that, but that lets you read text formatted data values. So we often will attach a scanner to a print reader, or I'm sorry, to some kind of a reader class. And that will allow us to tokenize the data as we read it off the screen. Okay, I think that is, well, let's just take a look at this one example that you've seen a couple times before, and then we'll stop there for a break. So here is an example of using a scanner. In this example, I'm attaching it directly to a file, but you can also attach it to a reader, and I'm pretty sure you can attach it to an input stream as well. So here we have this process file method. We give it a file, and we use that file to create a scanner, and then we set up our delimiter. So you can set up the delimiter to be anything you want. If you know how to write a regular expression, it can be whatever regular expression you want. This particular regular expression delimits by any line that starts with a pound. It considers that to be a comment, and this part handles any white space. So tabs, spaces, new line characters, any of those would be delimited, which means you're not getting any of those characters, you're getting everything in between those delimiters. And then you could just call, well, scanner has next, scanner.next, and that will give you your strings one token at a time. All right, so are there any questions about any of that before we take a break? We're actually, I'm sorry, I've been promising a break, but we've only got 2 more slides. So I'm going to go ahead and do the last 2 slides, then we'll take a break, and then we'll do database after that. All right, so here is an example of reading an entire file into a list. I find that I don't use this very often because usually I'm either tokenizing the data or I want to just read all the data with a stream. Those are the most common things to do. But sometimes it can be useful to just take an entire file, read the whole thing into memory, and end up with a list of strings. And so if we want that, we start with a file object, but we have to convert that to a path object. And the reason for that is this is part of a different API that Sun created later after the original IO classes. And so they created kind of a different mechanism for how it works. So that means I can get a path from a file, but I do have to convert the file to a path by calling get path on it. I do that within this paths.get method. So a little bit tedious there, but that gives me a path object. And once I have that, I just call this static read all lines method of the files class, pass in a path to the file, and that will read the entire file and give me back a list of strings containing the entire contents of the file. So that's a way to just read everything all at once in one chunk. Okay, and then the last class to tell you about is the random access file class. That allows me to basically skip around within the file and decide where in the file I want to either read or write. That's not actually very common. I find that I don't do that very often, but when it's what you need to do, it works great. So the random access file class keeps a file pointer. That file pointer points at the current location in the file. And so if you read, you're going to be reading from that location. And if you write, you're going to be writing to that location. And it will overwrite whatever's at that location in the file. So you have to be careful with it when you're using the random access file class. You can move that pointer around by either calling seek. When you call seek, that will move to a location starting from the 0th position or the beginning of the file. So if I seek to position 10, That's going to move me to the 10th position within the file, and then any read or writes will happen at that location. I can also just skip ahead. So if from whatever point I'm at, I can call skip bytes, pass some number, and I'll skip ahead that many bytes. If you put 0 there, you're not moving. And if you put a negative number there, it also doesn't move. Seems like skip bytes might go backwards if you put a negative number there, but according to the documentation, that's not what it does. It just ignores that. Okay, so that allows you to move the file pointer wherever you want it, and then to read or write from that location. And like I said, that's actually surprisingly uncommon. Mostly you want to work with streams or readers and writers, and sometimes with a scanner, but it's pretty uncommon that you actually have a good reason to use the random access file class. And all of these classes that I've just talked about are in the java.io package. So that's where you can find them, and you'll find many others as well. And so if you're looking in the documentation, that's where you can find all classes that do input-output, and they pretty much all throw IO exception or one of its subclasses. One of the common subclasses of IO exception is file not found exception. So you'll see that when in catch blocks and throws clauses as well.